We talked about points, lines, planes, segments. Well, yeah, talked about segments, lengths. Segments can be congruent, that kind of thing. And we talked a little bit about how to find the lengths of segments. We're going to talk a little bit more about finding some other, finding midpoints of segments, and then talk about finding the length of a segment when it's in the coordinate plane, but it's not a vertical or horizontal line, okay? And then we'll talk about angles. Now I'm hoping a lot of this angle stuff is just some review for you as far as identifying them, classifying them, and then find the measure, okay? We'll see how all that goes, okay? So the object here is for you to be able to find the length of a segment, find the midpoint of the segment in the coordinate plane. Again, we're going to name, measure, and classify angles, okay? The midpoint is the point on the segment that divides the segment into two congruent segments. Again, congruent is a fancy word in geometry that means the same length, okay? A point, ray, line, segment, line, or plane that intersects the segment at its midpoint is called a segment bisector. Hang on to that word, bisector. We're going to use that word a lot. Anytime you hear the word bisector, something is being bisected. Bi meaning two, right? And section means cut, right? So anytime we talk about a bisector, whether it's segment, angle, anything, that means we're just cutting that segment in half, cutting it in two, but we're cutting it specifically in half, okay? So here we talk about M as being the midpoint because it divides that segment into two congruent segments. It's right in the middle, right? So if we know that M is the midpoint, then that tells us that segment AM, and guys, symbols are paramount here. Make sure you get your symbols down correctly, right? So if we're talking about the segments themselves, segment AM and MB are congruent, and we use that congruence symbol, okay, that equal sign with the tilde above it, right? If you want to talk about the lengths of the segments, then now you're talking about two numbers, and two numbers are going to be equal, okay? So there is a difference in what you're talking about there symbolically. Let's make sure that we get that down, okay? Now, on the right-hand side, what you're looking at is line. Well, could be line CD or segment CD if you want to narrow your focus down to just the segment. But line CD, segment CD is a segment bisector of segment AB, okay? So if we know that it's a segment bisector, then we know the same thing. We know that segment AM and MB are congruent. And we know that the length of AM and MB are equal. Okay? I'm going to get myself in a little bit of trouble here. We never, ever, 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 ever go by the picture in geometry. Except sometimes. Okay? Does line CD appear perpendicular to segment AB? Anybody remember what perpendicular means? Crossing how? Right. Good. These guys making a right angle?
No.
Okay. Don't appear to be anyway, right? My point is segment bisectors do not have to be perpendicular. They don't have to make right angles. They can, but they don't have to. Okay? All they have to do is meet is touch in the middle. Okay? All right. Finding segment lengths, and we can use the idea of midpoints bisecting, that kind of thing. So here at the skateboard design, it tells us that segment VW bisects XY at point T. Okay? This is what I'm talking about, right? It doesn't matter if you look at that picture and you say, well, it doesn't look like it's in the middle. It doesn't matter. We just told you that VW bisects XY, whether it looks like it or not, it does. Okay? Now, XT is 39.9 centimeters. Can't really see that. find XY. We want to find all of that, okay? Oh, by the way, I didn't mention this on the last slide. Really probably should. Okay? Anytime we talk about two segments being congruent, we'll use tick marks to show that in a diagram. Right? So since AM and MB are congruent, we'll use these tick marks to let you know that. We're not, anybody will, right? You're gonna use tick marks to let me know that sometimes. Doesn't matter how many. You can use 1, 2, 7. Okay, sometimes you'll have a lot of different pairs of congruent segments in a picture, and so we have to keep adding tick marks. But any segments that have the same tick marks on, same number of tick marks on them, are going to be congruent. Okay. So anyway, back to this. So what I can't really see up here, and I wish I could make this brighter, is that since VW bisects XY at point T, we automatically know that XT and TY are going to be congruent. And so we know that if XT is going to be 39.9, then that automatically tells us that TY is also going to be 39.9. And so now we can apply the segment addition postulate to find all of XY, right? And again, a little bit elementary. But until we get really good at this, write that out, right? Okay, so double that basically. Add those two together and you should get 79.8, okay, centimeters. Okay? Issues, questions there, we good? Okay. Let's get through all of this. There we go. Okay. Another quick example here I'll walk you through. Point M is the midpoint of segment VW. Okay. And you got a picture here. You won't always have a picture given to you. So the idea behind having you sketch some things in the last homework has that in mind. Okay. You should be able to get to a point where you can draw that all on your own. So draw yourself a segment VW, put M in the middle, and then label it with your tick marks because you know that M is the midpoint. That being the case, we want to find the length of VM. Okay? All right, well, I've got segments here. I know from the segment addition postulate that this is true. Okay? So I could do something like this. So now I'm going to plug in. VM is 4x minus 1. MW is 3x plus 3 equals, what's VW? What are we going to say it equal to? Uh-oh. Right? Uh-oh. Okay, tricked you. That's not going to work out very well, is it? What can we do instead, though?
Make expressions equal to each other.
Right, they're the same. VM and MW are supposed to be the same, right? The same length. So that means 4x minus 1 and 3x plus 3 must have to be the same. I should have told you to hold your pencils, but just cross it out. Or erase it real quick. Can't do that. Sorry. But yeah, we do know that the length of VM is equal to the length of MW, so how about we just set them equal to each other? And then go solve. Okay? Collect all your x's on one side. I'm going to go ahead and collect all my constants on the other side. Oh, sorry, I didn't mean to do that. So we get x equals 4. At which point, algebra class last year, yay! Done. Right? No, we're not. Okay, not in geometry, we're not done. We got to go find the length of VM. We know that x is 4. No problem. Just come back up here and plug in 4 for x. Okay? The other wrinkle that you have in geometry is that very often we're interested in lengths, segment lengths, and angle measures. So make sure that you're paying attention to what you have to find. Sometimes finding x is enough, but most of the time we're going to want you to find the length of the measure of something. Okay? So be careful there. And you saw some of that in the homework from last class as well. Okay? All right. Don't need to see all that. No, seriously. Okay. Midpoint formula. Right? So if we want to find the midpoint, if we find out where it's located exactly, right? What we can do is we can put the segment in a coordinate plane and use coordinates to help us find out where that midpoint is. And it's fairly simple on how to do it, right? And since it's in the middle, we're going to have two sets of coordinates, x1, y1, x2, y2. And so quite simply, all we're going to do is find the middle of the x's and the middle of the y's. And how do you find the middle of the x's and the middle of the y's? You average them. That's it. Average your x coordinates, average your y coordinates, and since we're only talking about two sets of coordinates, that involves just adding the numbers and dividing by 2. And that'll get you your midpoint. Okay? It's a midpoint. It's a midpoint. Points have coordinates, so do make sure you keep your midpoint listed as a coordinate, an x and y coordinate. Okay? An ordered pair. Sometimes there's a tendency to want to add those two numbers together because you have to have one answer. Okay? We don't want to do that. Okay? So, quick example for you here, right? We've got a segment that we want to find the midpoint for. Segment SR, we have the coordinates there. We want to go find the midpoint M. Okay? Piece of cake. We know that all we have to do is average the x's and average the y's. When you're adding, does it matter which one you add or which one you write down first, or does it matter the order in which you add them? The answer to that is no, right? So all I got to do is take the x coordinates, which is 4 and 1, add them, divide by 2. Take negative 3 and 2, add them, divide by 2. And so the coordinates for m are just going to be 5 over 2 and negative 1/2. Okay? If improper fractions freak you out, turn that into a mixed number. It's fine with me. Be 2.5. Okay? Any major issues with that? Okay? We can zip through this. Now, we can use the midpoint to help us work backwards to find the coordinate of an end point, right? Coordinate planes are pretty handy. They give us a sort of point of reference, and we use them a lot more than what you may realize. When was the last time any of you guys held a paper map? Right. Okay. If you ever come across one and dust it off and open it up, it's just one big coordinate plane, right? It's how we give everything a point of reference. Makes everything a lot easier to measure and that kind of thing, right? Anyway, so we put this segment in the coordinate plane. We happen to know that midway between J and K is this point 2, 1. We want to know exactly where K is. Okay? Well, no problem. We know that in order to find the point 2, 1, we had to average those x's and average those y's, right? So we can make ourselves two little mini equations here, right? I know one of the x's, I know one of the y's, so I'm going to plug that in. So I'm going to take this, I'm going to make this 1 plus x sub 2 over 2, and that had to equal, well, 2, right? And then the same thing for the y's. I'm going to take 4 plus y2, y sub 2, over 2. When I average those y's, I apparently got 1. And so we just solved those two mini equations. What are you going to do first? To solve, let's work with the x equation first. What are you going to do first to get x by itself? Yeah, you could cross multiply. That's fine. Make this guy a fraction and have yourself a proportion and cross multiply. That works. Bottom line is you got to get that 2 out of that denominator. So multiply both sides by 2. That's a 4, obviously. And then subtract that 1, and you've got your x coordinate as 3. Do the same thing over here. Multiply both sides by 2. Ugh, this is a mess. So you'll have 4 plus y equals 2. Okay? Subtract 4. And y equals negative 2. I'll get better at this, guys, I promise. So your y is negative 2. So now you know that your coordinates for k are going to be 3 comma negative 2. Okay, so we're working backwards a little bit there. Does that make sense? Just setting up too many equations. Okay, questions? See a couple of confused looks. Is there any way I can unconfuse you? Okay. Boom, 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 boom. Okay, now, distance. If I want to find the length of a segment, the length of a segment is the same as the distance between 2 points. Okay? But not everything exists in vertical and horizontal nature. So if I want to find the length of this segment or the distance from this point to this point, then we can apply the idea of a right triangle, right? If you're downtown Indy, trying to walk around, you want to go from, I don't know, where you want to go from? Hard Rock Cafe to Lucas Oil. So you're going to the Colts game, okay? You can't walk straight there, right? It's a grid. You got to walk either down and over or up and over, right? In other words, if I'm downtown Indy, I want to get from here to here, then I'm going to have to walk here and then cut straight over, which creates a nice triangle, specifically a nice, what kind of triangle? Right triangle. Right, now we're talking about using the idea of the lengths of a right triangle. And so this guy's the hypotenuse. Not the first time you've seen probably the Pythagorean theorem, right? Pythagorean theorem has us working with the lengths of the sides of a right triangle. And in so doing, tells us that the square, this length squared has to be equal to these two lengths squared and added together. Well, that kind of is what we use to get to the what's called the distance formula, right? If I want to find the distance from here to here, I know that this is true. If I square that distance, then finding the length from here to here, which from homework from last class says all you got to do is subtract the x coordinates, subtract the y coordinates, because that's the only one that changes, and square it. And then find the length of this guy, which just means subtracting the x coordinates, because those are the only coordinates that change, and square those guys, right? But I want to find the distance. I don't want to find the distance squared, and so we simply square root that. And then you get to the distance formula, okay? This is formula. Basically, all it says is if you want to find the length of a segment, subtract the x's and square them, subtract the y's and square them, add them together, and then square root. Okay? So let's use that. What is the approximate length of RS with endpoints R 2, 3 and S 4, -1? Okay? And so we want to find the length of a segment. It's the same thing as wanting to find the distance from R to S. I keep saying that because that's going to trigger to you that, hey, I got to use the distance formula. And that's it. Pretty obvious question when you start getting into these formulas. Whatever. Do you have to memorize that? Are you ever going to be given that formula? And I don't know the answer to that yet. Okay? So let's just work on remembering it. Write it down as often as possible. So that just means take the x's and subtract them. What are the two x's in your 2 points? Anybody? Shout them out. 2 and 4. So subtract them and square them. How about your y's? 3 and -1. Good. Remember, subtract 3 minus a -1. We got to make sure that both those signs make it in there so that we understand that's actually 3 plus 1, right? Okay, 2 minus 4 is -2. 3 plus 1 is 4. -2 squared is what? 4? You sure? 4? -4? Oh, yeah. Yeah, that's -2, right? -2. -2 squared, we're going to square all of -2. Right, it's going to be 4. And the reason why I asked is because that's not what your calculator is going to tell you, right? If you just type in, especially if you have one of those TI 30s, or any of those calculators where you just type in -2 squared, it's going to tell you it's -4. Okay, yeah, just point that out because I see that happen a lot. Be smarter than your calculator. That's supposed to be -2 squared. All of -2 squared. Okay? So 4, 16. So the square root of 20. It says, it asks for the approximate length, and you've got, it's multiple choice. You see your answers are in decimal form, so you're going to want to go ahead and square root that. Mathematicians like to leave it at square root of 20 because it's a more accurate answer. But so we square root that, and should be pretty close to C, right? Okay. Any issues with the distance formula? Does that make enough sense? Okay. Get through all of this, blah, 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 blah. All right. Angles. Switch gears a little bit. Talk about angles. More definitions for you. Angle, 2 rays. By definition, an angle is formed by 2 rays that share an endpoint. Okay? The reason why I make a big deal out of that is because sometimes we need to identify the sides of angles. The sides of angles are always rays, so that when we identify them, we need to identify them as rays. Okay? So the sides are rays, so here are your sides. Okay? And then they share a common endpoint, and the rays do not lie on the same line. Although that's not exactly true, and I'll show you when they actually do lie on the same line and still form an angle. Okay? But they're not going to lie on the same line and go in the same direction. Okay? But there you go. The common endpoint is called the vertex. Okay? So the corner. Get used to that. Any corner in geometry pretty much any corner in geometry is called a vertex. Triangles have vertices, so do quadrilaterals. Okay? Circles, not so much. Prisms have vertices as well, plural of vertex. Okay? But vertex. Okay? Since it's a common endpoint, the vertex is a point. So if we have to identify the vertex, then we're just going to identify a point. Okay? So we talk about point A being the vertex. And like I said, when we identify the sides, we identify rays. So ray AB, ray AC are the sides of that angle. Now, naming an angle, you have a couple of choices. Okay? Not like segments. You do have a couple of choices when you're naming angles. You can use either the three angles the 3 points that form the angle, or if the angle's all by itself, then you can just use the vertex letter itself, right? So we could call this guy angle BAC, and we put a little angle in front of the 3 letters to make sure that we understand we're talking about an angle. If we left that angle symbol off, you might think we're talking about a plane, right? Because that's how we name a plane. Okay? The vertex is always going to be in the middle. When you name an angle, when you tell me the name of an angle, I should be able to put my pencil on the first point and trace the angle without backing up, right? Without going over a side twice. So the vertex always has to be in the middle. So BAC. Okay? Or angle, how else could you do it? Sure, nothing wrong with that. Angle CAB would be perfectly fine too. Okay? Or we can just, if the angle's all by itself, then we could just name this guy angle A. Okay? But it has to be all by itself. And I'm going to show you what I mean in just a second. Okay? Okay? Right. So for example, like something like this, right? If we're going to name the 3 angles in the diagram. And yes, there are 3 angles there, right? So the first question is, can you see all 3? Okay? Look at that for a second. Somebody pick out one angle. WXZ. Angle, and I gotta make this better for you guys. Or not. Sometimes it's supposed to be a little arc through an angle symbol. Sometimes you'll see that arc, sometimes you won't. It'll just be the angle symbol. WXZ, which is typically the one that people sort of lose sight of. So good. That's one. How about another one? XYZ. So if I put my pencil on X, I go to Y. Uh-oh. That'll work. YXZ. Okay. And then there's one more. WXY. Okay. How about angle X? What if I did that? How many angles have the vertex at X? How many angles vertex is at X? 3. Which one am I talking about if I say angle X? Who knows, right? That's why we can't, if the angle's not all by itself, we can't just use the vertex to name it, okay? we've got to use the 3 points. If it's by itself, then we're okay. More often than not, it's not going to be by itself, though. Okay? So good. All right? I don't think I missed anything there, right? Obviously, you can flip-flop the order as long as your vertex is always in the middle. Okay? All right. Measuring, protractors. You've got your protractor now, right? Quick reminder on how to use a protractor. Okay? First of all, we're going to measure angles in degrees. I don't think that's any shocker to anybody. Okay? And so we're going to use a protractor to measure the angles. There's something called the protractor postulate. That sounds a whole lot like the ruler postulate. Okay? But we should remember, at least as we get into using a protractor, hopefully remember how to use it. Okay? The only tricky part about a protractor is that most of them have two sets of numbers, right? There's a bigger set of numbers on the outside and a smaller set on the inside. Which one are you supposed to use? My guess is, especially after today, we're going to remember what an acute and obtuse angle is. You can use that idea to help you figure out which number you're supposed to use. But another good way to do this is when you line your protractor up, you're going to put the straight edge of your protractor on one of the sides of the angle. Wherever that side, whichever, however you put that protractor on the side of that angle, find which set of numbers that side goes through 0, if that makes sense, right? So right now, this angle is going this way. And when we put this protractor, the flat side on this side, the side's touching 0 for the smaller set of numbers. So you're going to use the smaller set of numbers to figure out what the measure is. I don't know. Tell me if you know all this and I can shut up and move on. Okay? Good. So anyway, we use a smaller set of numbers. We just kind of pick out what tick mark it goes through. It's just past 100. We're looking at 105 degrees. Okay? Like I said, you can look at this and hopefully in a second remember, oh, that's called an obtuse angle. So since it's an obtuse angle, I know the measure has to be bigger than 90, so I'll use the numbers that give me something bigger than 90. Okay, however you want to think about it. But that's your protractor, right? Like I said, classifying angles. Angles that are less than 90 degrees. You got it. Angles that are 90 degrees. We just said it, right? I'm supposed to be correct. But yeah, right angle. Angle bigger than 90 but less than 180. Obtuse. Obtuse. And then this is what I was talking about two rays being on the same line. You go back to the definition we have for an angle. Two rays can be on the same line. And if they are, they're forming a straight angle. They're also forming a line, right? And so a straight angle, the angle measures 180 degrees. If you do a 180, you've completely turned around, right? For you skateboarders out there, snowboarders, anybody? Skateboard, snowboard? Afraid to try. Probably break a leg. Okay. Anyway. Okay, there we go. Here's something. Or not. Check this out. Maybe. The YouTube is muted? Oh, God, come on.
Start we could use a little music. Music is expressly forbidden inside prison walls. My God, how can you be so obtuse? What did you call me? Obtuse. You being obtuse. 2 months in the hole. Or am I being obtuse? Now you're being acute.
Okay. So there you go. Kind of somewhat cute. All right. So, a little Family Guy humor there. Acute, obtuse. Okay? Use the diagram to find the measure of the indicated angle, then classify the angle. Okay? Can you take 2.5 minutes and find those real quick? Got your protractor? I'll give you 2.5 minutes to work on that. The measure of KHJ, I think, was done for you, right? Looks like it was. So we should have gotten 55 degrees. Ugh. We don't need to baby step this, do we? Okay, this guy should have been 55 degrees. And therefore is an acute angle, right? How about angle GHK? What'd you get? 125. Sounds reasonable, doesn't it? Which makes it what kind of angle?
Obtuse.
Obtuse. How about GHJ? Yeah. Straight, because it's, what's the measure? 180. And then GHL. Yeah, it's a right angle because 90 degrees. Okay? Just, because I like to be thorough, if you're going to measure angle LHK, you have to turn your protractor, right? Or turn your paper. Okay, so just be aware of that. If I wanted to measure LHK, I'm going to take the straight line on the protractor and make it lie on one of the sides of the angle. So you might have to turn the paper or the protractor, but yeah, should be good. Okay? Any questions, issues there? Okay. Let's get through all of this. Blah, 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 blah. Oh, there's a good one. Segment addition postulate. We have that, right? If two segments are linked on the same line, if they share an endpoint and on the same line, we can add them together to get the measure of a longer segment. Same thing with angles. If we have two angles that are adjacent, there's a word for that. It's called adjacent angles. Adjacent angles, think about what adjacent means. Adjacent lots, if you're talking about ever buying land, okay? It means next to, right? Share a side. If two angles share a side, but no interior points, right? So here we go. If we got P on the inside of angle RST, interior means inside, right? So if P is on the interior of angle RST, then it takes RST and basically separates it into two other angles. We saw this in a previous picture. Then we know that if we add the measure of angle RSP to the measure of angle PST, then they're going to be equal. And oh, by the way, when you start writing the measures of angles, the way we write that down, the way we show that symbolically is we just take the name of the angle and put a little m in front of it, like we did for the segments. Okay? But that's basically what the angle addition postulate means. If you take this angle, add it to this angle, it'll equal the bigger angle there. But that only works if the two angles are side by side, basically, right? Okay? So that's your angle addition postulate. So, a quick use of that. Okay, given that the measure of angle LKN is 145 degrees, find the other two angles. Okay? Again, angle addition postulate says that if we take the measure of angle LKM and add it to the measure of angle MKN, then that will equal the measure of angle LKN. Okay? I would start there first until you get really good at seeing this. I would start there first and then plug in what you know. Some of those look like, that's terrible. Sorry guys, my handwriting's pretty awful. Okay? So angle LKM is 2x plus 10. MKN is 4x minus 3. and it's going to equal the measure of LKN, and LKN is 145 degrees. Okay? There's your equation that you're going to go solve. Combine your like terms.
Is, okay, on
Mhm.
the first line, is it and then, angle, and then
Yeah, you mean right here?
angle? Yeah.
That's pretty awful. It's supposed to be the measure of angle MKN. Sorry. Does that make sense? Guys, you have to sometimes use a little bit of anticipatory reading when you're looking at my handwriting. Okay? I'll try to get better with this thing. Okay? And then we continue to solve. 6x is going to be equal to 138. Divide that out, and you should get 23. Again, algebra class, you'd be so excited you couldn't stand yourself because you found x. Okay? But not here. It asks for the measure of these two angles. So you're going to want to make sure that you go back up and plug the x in for these two guys and find out what those angles are. Okay? I'll leave that for you to do. Okay? Blah, blah, blah. Okay. Real quick, if we can get through this, we'll be in good shape. Two angles are congruent if they have the same measure, much like segments. And so again, we've talked about the actual numerical measure. We put the m in front of the name of the angle, and we say that they're equal. However, if we're talking about the angles themselves, then we use the congruent symbol. Angle A is going to be congruent to angle B. Okay?